All right, let's get right into it. Today, we're unpacking the world of distribution testing. Yeah, it sounds a little complex, but it's absolutely essential for anyone making and shipping a physical product. If you've ever wondered how your stuff survives that crazy journey to your front door, well, you're about to find out.
So think about it. You click buy, you get that tracking number, and then what? What really happens to your package between the warehouse and you? I'll give you a hint. It's not a gentle ride. It's more like a brutal obstacle course of drops, shakes, and crushing forces.
And because that journey is so rough, testing is how you get ready for it. This isn't about just checking a box. It's about taking all that real-world chaos and simulating it in a lab. You're making sure your product, and just as importantly, its packaging, can actually take a hit. So where do we even begin?
Well, your first big choice is picking which map you're going to follow. And for most people, the world of package testing really comes down to two main players: ISTA, which is the International Safe Transit Association, and ASTM International.
The choice here really boils down to this. Do you want a preset recipe, or do you need a whole professional kitchen to build your own? ISTA 3A is that recipe. It's a fixed sequence of tests, perfect for general e-commerce parcels under 150 pounds. But ASTM D4169, that's the professional kitchen. It gives you a framework of what they call schedules, and you assemble them to build a test that's custom fit to your exact supply chain. This is why it's so critical for things like medical devices, where you absolutely have to validate the process.
And here is a huge warning. If you go down that ASTM path, you have got to be specific. These standards are not set in stone. They change. D4169, for example, has had major updates to its vibration profiles for both air and truck transport in just the last few years. The bottom line? Always cite the full standard, including the year, like D4169-23E1. If you don't, you and your test lab could be working from a totally outdated playbook.
All right, so no matter which standard you end up choosing, your package is going to face 4 fundamental types of hazards. You can think of these as the 4 angry gatekeepers of the shipping world that your package has to get past to arrive in one piece.
First up, you've got the drop, or as I like to call it, the Butterfingers test. This mimics every single time a package gets fumbled, dropped, or tossed onto a porch. It's a straight-up test of shock resistance, making sure the product inside and the box itself don't just, shatter on impact.
Next, we have the shaky truck ride. This isn't some gentle buzz. It's a random, chaotic vibration that perfectly mimics the back of a truck or the cargo hold of a plane. The intensity is measured in something called G-ERMS, and this test is absolutely critical for finding that sneaky damage, things like scuffed labels, loose screws, or parts just getting tired and failing. Stuff a simple drop test would never catch.
Then there's the squeeze. Sooner or later, your package is going to end up at the bottom of a very heavy stack. This test simulates that crushing weight, but it's not just a random guess. It uses a computed top load. That means the force is calculated based on real factors, like how high the boxes are stacked and for how long. It makes the test incredibly realistic.
And finally, we have the Mountain Pass Challenge. This simulates low air pressure, the kind you get in an airplane's cargo hold, or even when a truck drives over a high mountain range. Now, for any product that's sealed, we're talking liquids, powders, cosmetics, food pouches, this test is completely non-negotiable. It's what stops your customer from opening their box to find a leaky, gooey disaster.
So we've met the 4 big hazards. But how do you actually prepare to face them? Well, success in the lab doesn't just happen. It starts with your homework. You absolutely need a pre-test blueprint.
And this blueprint right here is the key to saving a ton of time and money. First, you have to know your product's fragility. How much of a beating can the item itself take with no packaging at all? Second, you use data from cushion curves to pick the right protective material, and just as importantly, the right amount. Third, and this one is huge, you have to define exactly what pass and fail look like before you even start the test. And finally, you calculate the real stacking loads your package needs to survive. Doing this homework is what makes the whole thing meaningful.
Knowing what to do is one thing, but honestly, knowing what not to do can be just as important. So let's run through the most common pitfalls that cost people a lot of time and a lot of money.
Okay, this is a core principle you have to burn into your brain.
Any calculator you use, whether it's for box strength or stacking load, should be treated as an input for your test. It is not the final answer. These tools give you an amazing starting point, for sure, but they are never ever a substitute for a real physical test. The proof isn't in the spreadsheet, it's in how the package actually performs.
So here are the big red flags to watch out for. Citing ASTM D4169 without the year? You might be using an old, weaker test. Skipping the altitude test for your new line of shampoos? That's a huge mistake. Deciding what a pass means after you've already seen the broken product? Come on, that's not a test, that's just wishful thinking. These are the kinds of simple errors that can make your entire test completely worthless.
And all of this brings us to the most important point. If you're thinking of distribution testing as just another cost, you are looking at it all wrong. It isn't a cost. It's insurance. It's an investment in your product, in your customer's happiness, and ultimately in your brand's reputation. It's how you make sure the awesome experience you designed in your office is the one your customer actually gets to have.
So I'll leave you with this final thought. When you look at your own products, ask yourself this. Is your packaging truly designed and engineered based on real data? Or is it just a guess? Good testing is what gives you the answer. Thanks for joining me on this explainer.